Morning, everybody. Um, so this might be a very long video, and my apologies for that. I might have to break it up into two, hopefully not. But we're talking about section 2.1, and it's just general information. And we're going to try and talk about what is a line and how to graph a line. And a line is a series of ordered pairs, infinitely many ordered pairs that satisfy some type of an equation. So your equations can come in two forms. Actually, multiple forms, I should say. But if they're in a technically nice form, there's the standard form, which would look something like 3x plus 4y is equal to 12. Or in the slope y-intercept form, that's my abbreviation for intercept, INT. And that would look something like this, where the y is solved for, and the other two components, the slope and the intercept, are on the right-hand side or on the other side of the equals sign. So it really reads that the slope is listed first and the y-intercept is listed second. You can see them jumbled around in other forms, but they don't follow a nice form. And then there's another one called the general form, and it follows the standard, but it looks like this. It would be 3x plus 4y minus 12 equals 0. That's the general form. And you don't see that very often. We generally see stuff in the standard form or the slope y-intercept form, or some, mixed up form where it reads like x is equal to 2y minus 7, something like that. And you can see them where they're just read like x equals 1 and y equals 2, where they don't have the other variable present. Those are still lines. They just are either vertical or horizontal, depending. All right, so ways to graph. Let's go to what's referred to as the intercept method. And the intercept method is where you're trying to find where the graph crosses the x-axis or the y-axis. So we'll grab our standard equation down from below, which was at 3x plus 4y equals 12. And the technique is just make a table. And for your x value, you're going to select a 0. And you're going to take that 0 and you're going to replace that x with a 0. So you're going to have 3 times 0 plus 4y is equal to 12. And you get 4y is equal to 12 because 3 times 0 is 0. And then 0 added to anything is that thing. And then we're going to divide both sides by 4. And we're going to get the y value to be 3. And we're going to then let our y value be 0. And we're going to plug the 0 in for the y. And a little bit of scratch work here, so we'll have 3x plus 4 times 0 is equal to 12. And then 3x is equal to 12, and divide by 3. And so we get x is equal to 4. So we have 0, 3, and then we have 4, 0. And we graph those points and then connect them. So here's our x-axis, here's our y-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the x is 0, the y is 3. We set our mark. The x is 4, the y is 0. We set our mark, and then we connect our line. Okay. The table method is a lot like the intercept method. We just select values for either our x or our y. And so to be fair, this is really a table method, just with specific values chosen. So I could choose 0 and then 1 and then 2. That's very common. Many times I've seen or had students come to me and say, oh, my teacher always said just choose 0, 1, and 2 and plug them in. Nothing wrong with that. So we take the 0, put that there. So we have 3 times 0 plus 4 times y is equal to 12. We get 4y is equal to 12. We divide by 4. We have y is equal to 3. And so we still get that 0, 3 that we had. Take the 1, we plug it in. We have 3 times 1 plus 4y is equal to 12. We have 3 plus 4y is equal to 12. We subtract off 3, we subtract off 3. We have 4y is equal to 9. We divide by 4, we divide by 4. That was a little pencil or pen touch, and I didn't mean to do that. So we have y is equal to 9/4, and we can think about that as 2 1/4. 4 goes into 9 2 times. We have a remainder of 1, so we've got 2.5. So our ordered pair is 1, 2.5, and we plug our 2 in there, and we have 3 times 2 plus 4y is equal to 12. And well, that's now 6 plus 4y equals 12. Minus 6 minus 6, we have 4y is equal to a 6. Divide by 4, and we've got y is equal to 4 goes into 6 one time. We have a remainder of 2, so it's 2 over 4, which is 1.5. Now, if I'm over here on my graph, I have 1, 2.5, so I go 1, 2.5, and then I'm at 2 and 1.5, so I'm over to 2, and I'm up to 1.5. And those points are just more points on that line that we had. Now, slope y-intercept method. So the whole idea is to take the equation and solve it for the variable y. All right, now that means we've got to get this piece alone. We tend to move addition and subtraction first. So I subtract 3x, I subtract 3x, and I have 4y is equal to a negative 3x plus 12. And then I divide by my lead coefficient on the y, and I distribute it to each one of the terms. So I have negative 3 over 4x plus 3. Here's my y-intercept of 3. Well, that's what this is right here. And this says go down 3, and then right 4. Negative means down, positive means right. So from this point, from the starting point, from the y-intercept, I go down 3, and then I go over 4. And so I still get the same line. All right. I might have enough time to continue on. I have a cap on limits, or cap on times dictated by YouTube. So, all right. We'll talk about relationships between the 2 points. So you can have a slope, a steepness. Slopes can be flat, horizontal if the slope is 0. Slopes can be vertical, which in this case is undefined. So you've got this flat line for 0. You have this straight up and down line for undefined. Positive from left to right, it looks like we're heading uphill. And negative from left to right, it looks like we're going downhill. So 0 is going to look like 0 over some number, like 1 or 2 or 3, but not 0. 0 over 0 is well, it's a calculus issue that we would not deal with at this point in time. Undefined would have a 0 in the denominator with a number other than 0 in the top. Positive could either have a positive over a positive, or it could have a negative over a negative, because a negative divided by a negative is a positive. You'd have a negative relationship, so your fraction would be negative over positive or positive over negative, okay? So over here, I just got a couple of examples. And the slope formula, by the way, is y2 minus y1. So the y of the second point minus the y of the first point. The x of the second point minus the x of the first point. So this is the x of the first point, this is the y of the first point, the x of the second point, and the y of the second point. And so by the formula, we're going to go 0 minus 0 over 7 minus 3. Well, that gives me 0 over 4. Well, that is a 0 slope. Now, 0, 4, and 0, negative 1, following my coordinates again. Oops, I'm sorry. 0, 4, and 0, negative 1. So the y2 minus 1 minus 4, and then 0 minus 0. Well, I got negative 5 coming out of that top over 0. Well, that is my undefined. And is this positive or negative? Well, let's take a look. We got negative 2 minus 7 over 8 minus 3. Negative 2 minus 7 over 8 minus 3. So we end up with negative 9 over 5. Well, we have a negative number over a positive number. That means our slope is negative. Our line should be heading down from left to right. Okay. You can find the distance between 2 points. And the distance formula reads the square root of x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. And so our example is 2, 3, and negative 1, negative 8. So you take the square root of x2, so negative 1 minus 2, that quantity squared, plus y2 minus 3, that quantity squared. So it is the square root of negative 3 squared plus negative 11 squared, which is the square root of 9 plus 121, which is the square root of 130. Now we can break that down using the breakdown that we've done from radicals before and just see if we can get anywhere. So we'd have 2 times 65, and that's 5 times 13. So these don't have any duplicates, and this is prime, that's prime, and that's prime. So we're stuck with the square root of 130, or using our calculator to get a decimal approximation of the square root of 130. And last, we can find the midpoint between the two, and that is add your x's and divide by 2, comma, add your y's and divide by 2. So we're going to go 2 plus 4 over 5, divide that by 2. And then we're going to go 3 plus 1 over 8 and divide that by 2. Well, we should get a common denominator. So I need to multiply top and bottom over here by 5. So this will become 10 over 5. And I need to multiply top and bottom here by 8. So this is going to be 24 over 8. And so this relationship now becomes 14 over 5 over 2, comma, 25 over 8 over 2. And we put that in there. Now, remember what you do when you have a fraction over a fraction. You flip the second one and change it to multiplication. So we're really looking at 14 over 5 times 1/2, comma, 25 over 8 times 1 over 2. And so we get 7/5, comma, 25/16. All right, later today I'm going to try and post some example problems. All right, have a good day.